former president of ERMAC, joining you today to help out with the moderation of our session today, data literacy and the perceived failure of data management. ERMAC has been around since the 1970s and is an affiliate of DAMA International. And our speaker today is, in fact, the director of the chapter in China, Hong Kong. Really glad to have him with us today. He is formerly Ben Hu, our speaker is Ben Hu, who is formerly the Chief Technology Officer at World Bank, who was responsible for, of course, the overall corporate information technology, architecture, design, development, delivery, and operations at the World Bank's, for the World Bank strategy and mission in IT, and later the CIO advisor at the Securities and Futures Commission in Hong Kong, commissioner at China Securities Regulation Commission, and senior IT advisor at China National Council for Social Security Fund in Beijing. Mr. Hu has a BS degree in physics, an MS in computer science, and has done some graduate work and executive development work, and completed a program jointly developed by Harvard and Stanford for change management, accounting, and finance. He joins us today to talk to us about data literacy and the perceived failure of data management, and looks at it as a return to basics as well as looking forward to the future. And should we, at this moment with AI, machine learning, and advanced uses of data, should we consider what data really is? So without further, I'll pass it over to Ben and we can start our session. Thanks so much. Ben?
Yeah, okay, thank you, Deborah. My voice is okay?
Yes, it is.
Okay. I think a bit background on how the whole thing started. That was recently at the Dataversity that there were two articles related to the current coronavirus situation, and people felt data management has failed, right? And then the follow up another article, actually recently another one is data literacy. And actually then data literacy has been picking up some momentum, and I will talk about the way I feel, but that's the background. And so Deborah suggests the topic, we talk about it, but I think thank you for the opportunity. I wish we leave some room to have more interactive interaction or exchange of views, opinions, and that's the main purpose of today's talk. And I talk about my thought, and I would like to listen to and learn how you see the world of data. And we have 1 hour, right?
Yes,
Deborah?
we do.
Okay, until 6. Okay. So this is basically I will go through. I think I have been with, along with the career, I have been volunteering for DAMA community for some time, many years, and wish this community can grow, can pick up some momentum and catch up some new thing, because everything is data, although we call digital era, and it just the name changes, but fundamentally it's about data. And the thing triggered by reading these two articles, I don't know whether it's fair to blame data management for the current coronavirus situation. The whole world is suffering. And so all depends on what data really is, and whether the data is the data we are familiar with, especially in the DAMA space, or we should broaden the scope and understanding how other people are dealing with the data, not just us. So originally, I was a little bit afraid of getting to the human side. I know how complicated it is. But later on, I would talk about how I changed the perspective of data because of machine learning and AI. And I think they are really dealing with the data in a way, maybe, normal DAMA people, mainstream DAMA people, are not familiar with or a little bit feel foreign. But I will explain how I go through to see. I felt we are just part of the whole data life cycle. And if you really look at the end-to-end, the way the machine learning dealing with data, face recognition, voice recognition, actually they are at the beginning of how we bring the human dimension into the picture. And I think if we could combine these two, would be a good thing. And next one is we do have a persistent and stubborn issue remain in data management as we know it. I think we often repeat what we said. And the island, the integration, the difficulty of definition, and all those things, I really don't feel that we had made some big progress, if not breakthrough. So why is that? And also, I stress the human and data in at times that people feel whether this is a bit too academic. I mean, the human data and rather than data and technology and data and machine. And I now feel so close to human, and it's not just it's a natural. But we just don't think those are data before. The data to the human is the input, and we also output a lot of data, and the human play a role in between. And it's a never-ending learning, convoluted learning. It's not a one-time. Now we used to talk about the data source, the real source, lineage, then you produce a report. It's not like that. It's a continuously learning, right? And Carnegie Mellon now came up with the term the never-ending learning language or whatever. And also, I think there's a piece of science in it. I mean, the science is called cognitive science, which really research the cycle or the loop, and as I mentioned earlier.
And there's a book out now called The Age of Surveillance Capitalism by Shoshana Zuboff. And in there she quotes IBM as saying that we're heading towards the liquefaction of the world. And what's that about? That's about everything is now data. It's not just things in the world, it's IoT and it's humans as well.
Right.
They are all expressed in terms of data, the liquefaction of the physical world.
Yeah, but I if you want, we can discuss. But I think some people went too far. And the physicist, the very famous Wheeler, even think the whole world there's no physical, no atoms, and everything is just bits. I think it a bit too far, and that so that I will go through this. I mean, I think data exists in 3 different worlds, and they behave. The understanding of those are very different. So now the data and reality, and I think we all know in DAMA community, Steve Hoberman, I think William had the book Data and Reality. It's a small book, and mentioning a lot of things, the difference between data and reality, and what is reality, and the gap between them, and which has, if we have to understand right based on the current our cognizance capability. But anyway, so I try to step up with the definition of data. If you look at Google or everywhere, even I quoted some of the things mentioned in the DMBOK, the core concepts chapter, and there's nothing I can find bring the human into the picture of the data definition. And on the other hand is if you don't bring the human in, then the data is meaningless, right? And always too human. And now the machine is catching up, but still, the human is still in the loop. and I wish to leave some time to see. I don't know today's audience profile, whether what do people expect the next version of DMBOK. Deborah spent so much effort and time for DMBOK too, and we are very interested because a lot of new topics, new not hype, but there are new areas classical or mainstream data management are not familiar with. It's a separate group, either whether the blockchain or digital currency. And on the other hand is artificial intelligence, and so many different models, model intensive, data intensive, and so on and so forth. I think that we don't intend to be a brain scientist or cognitive scientist, nor becoming an AI developer, or maybe or the blockchain world of all kinds of new startup. But I think from DAMA perspective, a community, there are ways to connect with them. And I think recent discussion with the blockchain community, they only care about what's on the chain, but on the chain is still a very small part of the off the chain data. So there's a lot of things we can expand, derive from what has been built already, and connect with the rest of the new development. Okay, and then the last point is data literacy, and I have a few slides to demonstrate what it is in my mind. Okay, the talk, as I said, boils down to what data really is, from a human scientific perspective, and why it's important from coronavirus to the data literacy, 2 papers that as a reference for discussion. And we talk a lot. I think many people talk about data governance, and we spend many topics. The diversity of the industry, people understand the importance of governance. But the target, the object of governance, we govern the data. If we don't really have another look at or reflect that what data really is, then we may not be able to govern right or even manage right. And there's a whole series of issues will follow if we define data differently. It's quality, security, privacy. So I think it's a very important thing is if we see or define the data the same way, and as close as possible to the science, the data science, or the science about the data. And also, I think the world has been fundamentally shifted and even fast. Deborah mentioned also, and I think a lot of the confusing ideas, and it's a different world, and it will have impact the data accompanying in a different world. So we really have to open up our mind that to see how we can catch up or to connect or to partner. Then the one, I mean, the DMBOK stuff. I just quoted over here. I won't spend too much time on this, and everybody has a copy of DMBOK too. And I think it representing the facts about the world. And I don't find the whole definition there is the human dimension stressed and stored in digital form. Actually, data is not, as I'm speaking now, the transmission is digital, but when I speak, the voice is analog. And the way we think in the brain is also analog. So just focus on the digital side of it. It's just for transmission or for binary calculation. It's just the interim. It's not a really end to end. There's a lot of analog stuff on the end side. Yes. And there's the bottom part emphasize the electronic nature of data. I think ISO standard, and I don't know how many people are using ISO standard. 1179 in the beginning, I was very excited when I did as a VP for standard in DAMA International, but I didn't find too many people care about it. I think looking back, a lot of core concepts of the data may not be right. So if we emphasize electronic nature of the data, you miss the big piece of it. So I wish to learn or to understand the human side of the data, which is the beginning of the data. And the electronic part is make things faster, propagate farther, quicker, but the end point really, the semantics part of it, the meaning part of it, the definition part of it, the classification part of it, it still comes down to human. And okay, now I want to say, I mean, the paper said data management has failed and present us with a historic opportunity. I think we really have to understand what data management was referred here, and the historic opportunity is whether we will resolve the data problem once for all, or whatever. And I presented this, actually this picture, many scientists like it very much. At the time when the big data came out, and usually scientists handle a large volume of data, and we had a seminar, and quite a few scientists came and to talk about. They heard of the big data and try to understand what it is. And on the lower right, but who have divided them? right? It's now they call data pieces, right? And scientists, they all would like to collect all kinds of different data, right? From macro, from to micro, to virus, to immunology, to. So as I mentioned before, it's still very difficult to pull data together, and without understanding the human, all humans are involved in the whole process. So there is an international organization called CODATA. Right? It's a consortium for the scientists, and there's also a COINFO. Deborah, I don't know, it's also a coalition for information science.
We'll publish it in the comments later after the session.
Okay. So I think that if my view is return to the basics, real basics, what data really is, and forward to the future is the same thing. I think if we really come to the basic, have a reflection on what data really is or is not, and then we are ready for the future. And in the future, the data and human will be, we understand they are so closely, every second, we are dealing with the data. If we define the data differently. The recent development in machine learning, I mentioned earlier, and AI really is the trigger point for me to rethink what data really is, because the subject they are talking about in our mainstream data management, we don't touch that, right? And then when you do face recognition, voice recognition, natural language processing, pattern recognition, really pixel, right? Pattern, and I also will describe that we started with a different stage of data life cycle, not from the beginning. From the beginning, people observe, hear, right, see, and these are the data, which are very different than what we normally, mainstream data management professionals do. At that time, it's already way down the face of a data cycle. And this is a slide that Deborah also, Canadians are very good at artificial intelligence, and the few of the best scientists in that area are Canadian. And Hingden made a speech at the award, Turing Award, and I think he said they spent 50 years just to try to have, describe what they see, right? Like this picture, a close-up of a child holding a stuffed animal. To human, it seems to be very easy for machine to do that. 50 years, right? And but the input is image. The input is not the one we normally would do for data. The other one, Jan is also talk about, and I think I can closely relate to what he meant. Is also we talked about physical earlier, that by observing the world, and that's exactly the AI or machine learning is trying to do, just to observe. And also comparing with the baby. So the lower left part of it, and these babies, really not even kids, what they are doing. But in my definition of data, they're already dealing with the data. They cannot even speak, right? They know the mother's face. They they fail, they feel pain, they posture themselves to start walking, and all are struggling with the data around them, right? There's a door you open, you can get in, you cannot bump into it. All this thing is quite, when babies were born, as they start doing with the data, not until far later time. For difference between our way of dealing with the data management versus the machine learning, I said the traditional programming versus machine learning is I saw this is a course, I think, by Stanford that they compare the traditional programming with the machine learning programming, right? The traditional programming, I think, including database programming, our kind of work. And we know the rules. We want to understand what the rules are. Then we want to know what data is. Then finally come up with the answer, whether it be business intelligence or something else. The rules also, definition, the categorization, dictionary, and annotation, all these kind of rules. And they do the machine learning did the other way around. They first input this answer. They want to put the answer and the data in, then figure out what the rules are. So the methodology-wise, approach-wise are different. But as I said earlier, I feel by observing things without any rules, without any boundary, or even knowledge, then coming up with the knowledge is more natural than what we do. And the machine learning, whether mainly statistics or not, it's the classification definition coming out in the end, not in the beginning. And our way of managing data, we have to get that done first. Then we come up with a different kind of answer, right? So if we can combine these two, I have a picture, and I think it would be nice that when the machine gets more powerful, faster, punching data far more than we could. But on the other hand, I think we deal with a lot of data every day. If you think of when we wake up every day, right? And we watch, we drive, we work, whatever we see, whatever we hear, if we define those as data, the amount is huge. The brain is able to handle that, store that, to remember that, to process that, to make decisions with it. It's truly amazing. But that's the data I try to get into. These are also data, so close to human. So this is data is whatever human can sense and produce directly or indirectly by tools or instruments, because some of the stuff we cannot see directly, whether we build instruments to see that, right? But regardless, it will end up with human sensory, right? Perception and conceptualization and so on and so forth. And also what we put into machine for it to execute actually is also human. And I don't know whether we can say, we talk so much about the meaning, semantics, and semantics modeling, whether in the machine really knows its meaning. I still think at least quite a part of the thing still in people's mind. They didn't express well, and remain depending on the scenario, they only need to express part of it. Representation is not complete, but we have to get human in the loop all the time when we talk about data. And this is the picture I felt in the last maybe 10 or 20 years. We really didn't make much progress solving the data island issue, the meaning issue, the consensus issue, and this this diagram, the both sides, it's a normal. What I want to say is that in the middle of it is a communication process, and this process, human to human communication, is absolutely necessary. I cannot imagine that that even we digitize everything, the human and human voice communication, video communication can be substituted, right? So, and there's a lot of stuff going on over here. We still need to pay more attention because these are data also. And the language is becoming data. Language becomes, the data is a major thinking shift. In a recent talk on data governance, I raised the issue on the legal side. Actually, the law is the representation, and the representation come around and regulate and supervise the data. So this is convoluted, but that's a reality. This is also a slide, data creation and knowledge. The upper over here, the upper left is the object world when people see. Then after see, actually, over here is the representation. But I think it would be nice if you have a human here somewhere, because the representation and this object world, you go through human, right? And then coming down, and the result is data. The knowledge encoded in data, right? And I think the knowledge is still in humans' mind. And we, at the bank, I had a huge project called data management, knowledge management, spend a lot of money, making some progress, but at large, it's very difficult to manage knowledge, especially implicit knowledge. And people would not express them, not holding back, but depending on the context, the data expressed or represented is still small portion. And the knowledge you want to be encoded as data, as a language or even as a table or whatever, or knowledge graph, is just it's useful. But I as I said, I think I still stress that the humans dimension, humans need, because once you codify and coded in data, that's it, right? And we know how difficult to change it, and costly to change it once the data is in the system, and it's still so different from the machine and the people. And this is also what I said. I added should it be from and to. The knowledge from data, then you come back to knowledge, right? How do you make progress in cognizance, and how do you gain knowledge through data? So from data and to data, and it's a loop, as I alluded earlier. Human and data. If not with human, what's the use of data? If we don't exist, then the data is there, and and the meaning is still produced by human, right? And there's some differences between natural science, the data meaning, versus. I have another slide, and the social science, finance, and the medical science in between. Part of it is science, chemistry, physics. Part of it is still experimental, psychology, and this kind of stuff. The intimate and inseparable relations since humans are born. I think we have to change the view that people dealing with the data, once they go to the college and, start learning the computer science or data science or whatever. And that way of looking at data is too narrow. And again, once the human in the loop, I have a diagram, so it's not just output, it's not just the input, it's not just a one-time input output, it's a continuous. This never-ending loop I mentioned, and I think there's a science of it. Very few, I think, mentioning even in the data science, it's a cognitive science. I think we need to know a little bit, because the cognitive science, if you have a bit of a research, know about it, is exactly the human perception, conceptualization, and the language. Language is also a part of the cognitive science process on the way out, going out, and the perception to conceptualization is the way in from data. This is the picture I mentioned about. On this one, it's and the eye, the ear, right, and then some of the symbol, and you go to the voice, and this is a very complex process going on with a neural network, right? This one is the two people communication, and this one is speaking, and this one's listening. That's what I said, that the digitization, digital, we use so many terms. The digitization is the middle piece, transmission piece. Two ends are still analog, right? It's just a voice, it's a sound, right? And the information theory that Shannon made a great contribution is just this piece. That didn't Shannon, wrote many papers, and I think some of them he stressed the communication, the information theory really didn't get into the meaning of it. Just make sure the bits transmitted properly and the computer, the bits processed quickly. The meaning still depend on human. I have to pick up a speed. Over here, we have two people. I'm sorry, there's a Chinese at the bottom, and I didn't have time to change. And what I want to say is X1, X2, X3. X1 is from the concept to the mouth moving to generate sound. And this X2 is not the same as X1, right? And then X1 to the lady side, then they go to X3, because when she hears the sound, it becomes a concept. So this is X. The Y is the reverse. And they argue like we oftentimes that we don't agree with a particular word, the meaning of a particular word. We argue back and forth. Finally, we may end up a new concept Z, because when you have X2, the sound going over here become a concept, conceptualized, become X3, depending on the experience and perspective and the knowledge of this lady. It's not a straight through, just X1 becomes X3. So this is a complicated process. That's what I want to say. And over here, it's also actually single person. The sound coming in, and 2 is conceptualization process. And then you have a language process, you speak out. And 2 and 3 are the most complex phases. And we don't get into it, but we have to recognize this is the scientific process. And this is also, I think I quickly, and I view there are 3 worlds. And I think it, even for a simple dog, a boy has a puppy dog, and the girl has the puppy, very nice small dog, and they see it. Then their grandparents teach them this is called dog, right? This is how to ride, and finally they pick up the concept. Then this is one world. This is the left side is the world of real object. And there's a lot of in the middle conceptual subjective world going on. We really don't know the mechanism, how brain works, although some progress made. But so anyway, this is the second world. We don't talk a lot, but the right side is the world of representation. So I just want to stress some appreciation, the process when you see the dog, to the dog concept, to the representation, whether you write it down or you put it into the definition of a database, it's not far more complex than what we imagine, right? And also these two, I want to also stress, the boy and the girl, when they talk about dog, normally they know what the dog is. But if you want to add attributes, the dog, whether it will bite or not bite, the dog is friendly or not friendly, they may disagree. So these two concepts may not be the same. I'm pretty sure it's not exactly the same, right? So even though, and on this side and this side, if you want to get connected through humans, all right, that's why the human data. This is, I just put the computer into the, right, and these are the two people, and everything, data is everywhere, right? Over on the left side, it's a signal produced by nature, all kinds of your light, the sound, all kinds of nature, and they produce data. And then over here, I have perceived by humans, some of them, perceivable, some of them not perceivable. Then if it's human, they go straight. If not, they go to the embedded system. Deborah mentioned IoT or whatever. It's a processing, and then you come up with the data, all right? And then coming with the physical signal again, then I continue going on. And then if some of the signal initially not perceivable, then after the processing, then become displayable, then become a human perceivable. I mean, it's a complex diagram, but I think it's quite comprehensive, and I show people and try to see whether anything piece is missing. But the most important part is in the middle over here, right? It's and this is also quickly, two people viewing the same thing, reading the same paper, and they are not the same, and then disagree. Then we have to sit down, build a consensus, and it's, and this one I think I use as very famous. The data mining, CRISP, the diagram. And there are a lot of terms used, I think is not really scientific. And the data understanding, what's data understanding, right? Business understanding, you say, oh, people understand. Data understanding is still human, So this diagram, if you put a human dimension in it, I think it will be far more useful and complete. And over here is the evaluation, right? And feedback. Over here is, if I were to rewrite, I will have the human, just like the earlier picture, the human have to be there. So we make the whole picture more complete and scientific. Berners-Lee, right? The internet inventor, especially the semantic web stuff. And in the conference, he just said, because machine readable is also a term used quite broadly. Like you feed the stuff there, the machine can read. But what's read, right? And it still bits, processing the bits. So he now is inventing the next version, trying to invent the next version of the internet, and he said still asking people to make the extra effort. This is the extra effort what the human adding the value. Okay, now literacy or illiteracy. In the beginning, you know, I have a picture of all the scientists working on data, and this is the NIH, the U.S. Institute of National Health, National Institute of Health, the top scientists of life scientists, and I attended one of the seminar there, and it's from data to discovery. The data to discovery is a very, very complex process. So I don't think the coronavirus, we can blame the data management because it involves a lot of painstaking, difficult research. It's not like we learned the DMBOK that perfectly, then we will not have this problem. It's still far from it. And this is also just the one of the knowledge graph. You see how complicated it is. And to try to understand this virus, it's a very, very difficult. Until today, we still don't know what this particular virus, right? With the mask, without mask, and all this stuff, still learning. It's an unavoidable learning process. And I think literacy may help because it's not just a grammar school kids, and it's also the ever learning, never ending learning, and people have to build up the data capability to process those. This is the one is about the Fauci is the best scientist in this particular area, and he said Donald Trump understand right away when he saw the data, but it didn't turn out to be true. Right? I mean, maybe one time he thought what should be done, but right away. But the next day may not be the same. And this is the one I showed Deborah before. My grandson, the third grade in Toronto, and I just flipped through his textbook. I found there's a data management there. There's how to organize data there, how to communicate about data, the important stuff we talk about. The kids started learning, and that's what's happening. This is when I selected a few about data literacy, right? And you can see library, faculty. This is the Purdue University, and this one I think is Carnegie Mellon. So it's a spectrum, wide spectrum of data literacy. We have to rethink what data really is, and that's part of the data literacy. We really have to build, and from ordinary people, from scientists, from our profession, we really have to broaden the understanding what data really is. Oh, okay. Now, talk so much about it. What's the solution I see? What I think this picture is the learning and discovery, and as I mentioned earlier, the human in data. Yeah, that's a process for learning and discovery, for scientific discovery or business innovation or whatever. And the right side basically is what we do, right? Including unstructured, right? Mostly structured. And a concept representation, the key is the representation, right? Based on model. And I stress the human-centered cognitive process. We are here. And the left side is the machine learning process, right? They classification, clustering, and all the stuff, pattern-based statistical model, and they do over here. We're not sure whether this result will match with the right side. So human has to be in the middle, right? We have to see whether that makes sense or not. maybe we overlook over here and they produce something which is very likely and increasingly likely there are some. But in the end, we still have to match these two. And I think there are many, many cases or examples of that. This is the same thing. And the key thing is the term definition, the classification over here. Then classification is very closely related to definition. So over here is the enterprise data model. They have also definition over there. And again, there's a loop over here, and we are in the middle. And these are quite real, right? And we have to bridge these two and match with us. A little bit of what we do, DAMA China, and hopefully we can work together with DAMA Canada or Toronto. I think what I really find that DAMA basically is in the middle here. Data structure, data model, the whole DMBOK. And now we try to get into the business side, and the business side, the management side, and the board side. We have to go through, right? Because we all are talking data. The language may be different, but we have to get connected. The other thing is horizontal. There's a major issue for cross business unit, cross departments, and cross domains. We have to do, and the real hardcore, the computer networks, operating system, DB engine may not be our main focus, but our main focus is getting into the business side. The governance side, we even have to go all the way. Okay, Deborah, I think let me just stop that. We love the DMBOK so much, and we really hope to get involved with the next version DMBOK. With some of the stuff today, I touch base, and DMBOK can be more encompassing, inclusive, and bring those new development into the knowledge base. And why the nonprofit, independent, open is important, and I think Wiki. I think just before the presentation, the Wiki, try to find the definition in Wiki, they pop up with this. And I think it said very nicely that it's so cheap, we take it for granted. And they provide enormous value and with enormous amount of effort behind the scene to make it a Wiki. I don't have to say much. I think everybody knows. And I think DAMA organization would like to follow the example in the data management space. Okay, thank you.
Well, thank you, Ben. That was a really interesting discussion. We don't reflect enough, I think, about the things the way we think, the way we communicate, and how that feeds into our whole profession and our practices about data management. Thanks so much. And also about the DMBOK and being it being a reservoir and being a reference for some base practices to engage in. Thanks very much for today's today's talk. We'll be posting below various links based on the talk today. And I'll turn it over to Nick now to see if there's any questions from the audience.
Actually, it was no real questions from the audience. Thank you so much, Ben. Yeah, that's it from my side.
Right then thanks very much for joining us all. Please follow us on our YouTube channel. And also look for us at ermac.ca and also on LinkedIn. Thanks so much for everyone for your attendance, and we'll see you again next month.